Welcome to the first lesson in this series. Some of the things that we're going to explore is how the camera works and how it can translate into developing a really great video. This is basic video production, so it may seem kind of strange to start with a still camera, but it's really going to pay off in the end. So I want you to think about your camera, and if you have a newer one, you might have multiple lenses on your camera. And those shapes of the glass in the lens really does play a huge role in how your subject is going to appear in the final project. So I want you to think about a fisheye lens or a really wide lens, how that might distort your person that you're taking the photo of, or how it might distort the landscape. Well, all of these things are going to play a huge role as we explore how to develop a video for this class. So let's jump in to our first lesson, how the camera works. Wyman Menzer is the only state photographer of Texas. He has many years of experience exploring and capturing almost every corner of the state of Texas on film. He often describes what he does as chasing light. He constantly is in search for the first and last ray of sunlight. In this lesson, you will begin to explore the unique relationship between the camera and light. Here are our learning objectives for this learning module. You'll review these at the end of the lesson. This is a great way to gauge your level of understanding of the material. At the end of the lecture, review these objectives and ask yourself if you understand everything. If not, reach out for help or revisit the content from this learning module. It may seem odd to begin this lesson about cameras with the eye. However, the camera design actually imitates the eye. Like the eye, it sees by means of a lens which gather light reflected off of objects. The lens directs this light onto a surface which senses the pattern formed by the differences in brightness and color of the different parts of the scene. In this case of the eye, this surface at the back of the eye sends the pattern of the light to the brain, where it is translated into an image which we see. Here is a diagram of the eye, gathering patterns of reflected light, which the brain translates into those images which we see. In the case of the camera, the lens directs the pattern of light onto a variety of sensitive surfaces. Still film cameras record light patterns on a film coated with light-sensitive chemicals. The chemicals react differently to different amounts and colors of light, forming a record or image of the light pattern. After the film is processed in other chemicals, the image becomes visible. In this diagram, we can see how a still film camera records light and the patterns of those lights on film coated with light-sensitive chemicals. You'll notice that both the lens of the eye and the lens of the camera turn the light pattern upside down as it passes through. This is because they're both convex lenses, or lenses which curve outward. Because of their physical properties, convex lenses always invert images. In the brain and in the camera viewfinder, the images are turned right side up again. Now that we've drawn some parallels between the eye and a still camera, let's move into how a movie camera works. Movie cameras record images in the same way as a still film camera, except they do it more often. 8mm movie cameras normally take 18 different pictures or frames every second. 16mm and 35mm movie cameras take 24 frames per second. When these pictures are projected on a screen at the same fast rate, they give the illusion of continuous movement. The viewer's mind fills in the gaps between the individual frames due to a physiological phenomenon known as persistence of vision. Movie cameras take many different pictures every second. The number of pictures taken per second is called the frame rate. DSLRs are unique in that you have to set the shutter speed as well. The rule of thumb is that your shutter speed should be twice the speed of your frame rate. So, if you're recording at 30 frames per second, you want your shutter speed to be 1/60th of a second, or faster. In digital cameras, both still and video, the lens focuses light patterns onto an image sensor, either a CCD, charge coupled device, or a CMOS, complementary metal oxide semiconductor. The surface of the sensor contains thousands of millions of tiny light-sensitive areas, called picture elements or pixels, which change according to color and intensity of light hitting them. In video cameras, the image formed by all the pixels together electronically collected off the sensor as a rate of either 25 or 30 complete images per second. These images can then be recorded or broadcasted. As you can see in this diagram, video cameras convert light patterns into electronic images. At the viewfinder or TV set, the process is reversed to recreate the original image. Persistence of vision causes the viewer to perceive the separate pictures or frames as continuous movement. The image formed on the retina is retained for about 20 milliseconds, even after optical excitation has ceased. This property of the eye is called persistence of vision, an essential factor in cinematography and TV for obtaining the illusion of continuity by means of rapidly flashing picture frames. A thermotrope is an optical toy that was popular in the 19th century. A disc with a picture on each side is attached to two pieces of string. When the strings are twirled quickly between the fingers, the two pictures appear to blend into one due to persistence of vision. Take some time and review the learning objectives for this learning module. Be sure to ask yourself if you understand everything. If not, reach out for help or revisit the content from this learning module. So I hope everything in this lesson is making sense and you're excited to learn more. In class, we're going to actually create a thermotrope and we'll get to see persistence of vision in real life happening before us. So be sure that you prepare for class and come excited to learn some more about how the camera works.